Okay, I hope I'm audible. Good evening. I am Shreya and I will be the TA for this course on applied statistics and econometrics. Really sorry. So I hope you can see my screen. Somebody, if you can please respond, it will be
Yes,
really
we can.
nice.
It's visible.
Oh, it's visible, right?
Yeah.
Okay. So, thank you. So, before starting, I have a few points that I would like to say. So, this meeting, I'm not sure, it might get disconnected after 1 hour. So, if that happens, please use the same link to rejoin. Okay, I am not sure, it might not happen, it might happen. In case it happens, please use this link to rejoin at after 1 hour. And having said that, I'll discuss week 1 problems today. And I hope every one of you have gone through at least the course content. Is there anyone who has not been able to go through the course content till date? Okay, so I'm assuming you all know the content of week 1. And if there's any doubt, even before starting, during when I am, trying to address a few doubts that I have seen in the discussion forum, and I'll try to solve a few problems also, which will help you with the assignments. But in case if you have any doubt, you can feel free and you can ask me even now. Okay, so I'm assuming you don't have uh, some doubts, but anyway, as I go along, if you feel anything or if you have certain questions, please feel free. Okay, so I'll just start with a brief overview of what has been discussed and how we can go about solving the problems. Is it fine? Shall I continue? Yes, thank you.
Yes, yes.
Yes, okay. So the first thing that was discussed in these lectures was what is meant by a theory. So, what do you think? I want this class to be a little interactive, so I would like to get your inputs. So, what do you think? Have you understood by a theory? Anyone?
Hello.
Yes, yes, you're audible.
Yes, ma'am. Ma'am, theory is the explanation of events
Okay, okay.
uh,
And
and it's a relationship between two attributes, I think, two or
okay,
more attributes.
okay. So, this broadly speaking, this is some kind of idea that we already have established. And what is an hypothesis? What do you think is meant by a hypothesis? You don't have to be like correct, like you don't have to quote the textbook, just your idea.
Assumptions,
True, assumptions.
statement, a
Exactly.
statement or assumption about
Based
the
on,
relationship between the two variable or
yeah, based on your assumptions are based on are guided by certain theories, right?
theory, right?
Yeah. So
We
here,
can say like that, no hypothesis, any statement about the population parameters.
exactly. So if I speak statistically, then it's a statement about the population parameter. But in a general sense, hypothesis is some assumption about the theory that we have. Okay. So this is done. What do we mean by a population? So give me an example of a population. Anything.
When population refer to the complete set of items or elements.
Uh, okay. And sample.
No, sample is drawn from the population only. Acha.
Okay. So let this be my population. Okay. Here are a few observations or individuals, if I say in the, for that matter. A
Those are
sample,
samples,
and
I
these
guess.
are the samples which constitute the population. So,
Yeah.
what is the difference between a representative sample and a random sample?
In representative sample, probably on a first hand we decide some kind of characteristic that should be there in that sample. Probably we are not randomly in a population of India, we are not
Mm-hmm.
randomly selecting people. Probably we are doing a study in a teenage age group, so probably
Mm-hmm.
we'll study based on the people from 12 to 18 years. So that's
Yes.
kind of representative sample, while we are just randomly asking any question, like studying people. So that's probably the normal, like random sample.
Okay, so a random sample means that from anywhere from India, let's say this
Yes.
entire thing is India, from anywhere, any state or any place each individual has a chance of getting selected. That will be
Yeah.
a random sample. But if I want a representative sample pertaining to the teenagers, then that age group will be a representative sample. Is this what you are
Yes.
trying to say? Yeah, more or less
Yes.
on the correct lines only. Yes. So that was discussed, and a few techniques for organization and visualization of data, that was also discussed using descriptive statistics. Now that will give us a first hand view of the data that we have at hand, right? So we want some information from the data so as to infer or conclude. So the first step of any data analysis is to get some visualization, to get some descriptive measures that will guide us to formulate hypothesis, and that in turn will finally lead to some inference about the population under consideration, or rather a population parameter that is under consideration, right? Am I making sense?
Yes. Yeah.
Okay, thank you. Yes, and also it was discussed what we mean by a variable. If you can brush up, what do you understand by a variable and an observation?
Attribute that can take on a different values.
Yes, that can be quantified in some sense. Okay, and observation is the value of the variable, and the collection of all the observations is what we refer to as a data set. And there are different types of variables. It was discussed, one is the independent variable and one is the dependent variable. Can you give me an example, a situation or an example where you can say one is an independent variable and the other is a dependent variable?
Like y is equal to mx plus c, equation simple. So x is our independent and y is our dependent variable on x.
Okay, so but we can also
Second,
write this thing like x equal to.
one of the examples may be people. Sorry to disturb.
No,
What I'm
it's
saying
fine.
is another example may be the life expectancy versus smoking a cigarette. So that may be like
So this is x or y.
dependent variable. That means
Life expectancy is x or y.
smoking cigarette may be the dependent variable. Yeah,
Okay,
that is
smoking
yes, that is right.
is dependent, as you are saying.
Mm,
That is dependent. I'm saying living a life till 65
Hmm.
and living a life till 70. If somebody is living a life at 65,
Hmm.
stating that he is a smoker,
Hmm.
then life expectancy goes down due to smoking. If
So,
that is the statement, then life expectancy is the dependent variable of
exactly.
smoking.
If that is the case,
so
that smoking is affecting,
the function.
yeah, this, sorry,
I mean, smoking is a function in that case, I guess.
life expectancy is some function of smoking. If that
Yeah.
you want, if that is how it's
Yeah.
affecting. Okay, but this one we try to model with some sort of functions like y, sorry, y equal to some fx plus some error term is involved in that. This will be our model, and finally we get estimates of the functional form of fx, and then we get the predictions of y. But does that always imply causality? Like if we get some relationship, if fx is, let's say, it's defined, does that imply that smoking is causal for life expectancy? Can we say that?
No, there should be
No.
like correlation should be there. Like if it's less than one, we cannot say like it's one probably the I mean, the probability increases. Like the way you start increasing your smoke, it may cause. But what I say is like if I took an example from share market, so an Adani Nifty has a good weightage. So if Adani stocks are going down, so there's a high probability that the Nifty itself will go down because of the high weightage. This case, they have a positive correlation. So if Adani stocks goes down, then Nifty also goes down. And and like they have probably the positive beta case that's related to share market. So but there are some stocks when Nifty goes down, but those stocks are probably sometimes go up. Probably they have a negative beta, or sometimes they act like a very neutral. They don't go up or down that of Nifty, because they are very, let's say, some FMCG stocks, they don't fluctuate that much.
Okay.
So their correlation is not very less with the overall market, probably. They're
Oh,
indifferent to the market.
okay. So if I can summarize what you have said right now, here X is the Nifty stock and Y is the FMGC, or sorry, fast moving. What was I am not from an economics
Fast,
background, so you can
yeah,
guide me here.
FMCG product, fast moving
FMCG,
consumer
consumer
goods.
goods. Okay. So these products, the beta, if it is negative, then when the Nifty stocks goes up, these stocks go down, and some sort of relationships. That's what you're trying to
Yes.
say, right?
Yeah.
Exactly. So this is somewhat a measure of correlation, but this is we have to be very careful not to term it as causality. Okay, correlation does not always, sometimes it does imply causality. So this thing we should be very careful of, but you are right. Okay, and another thing that was discussed was the types of variables that we have under consideration. Now, why do you think such granularity is required in knowing what type of variable, what is the variable that we are dealing with? Any idea why we have to, segment and categorize, like these are qualitative, these are quantitatives? Why do you think so? Just a general idea.
So probably, if you're doing a sample study and there's a response from yes or no, you
Hmm.
can directly say it's a positive, but like they have accepted or rejected,
Hmm.
either way case.
Hmm.
But when you are referring to a scale of 1 to 10, then you can somehow see that these you can probably let's say can draw a normal distribution curve also, like this much of the population is it's somehow very much agreeing to the to our hypothesis assumption, while they are somehow neutral, this portion, like probably in a 1 to 10 they have I strongly agree with you in that case, like they have given you 9 to 10 while they are not agreeing, so they have to choose 0. So you can segregate more, there's a lot of segregation you can done based on that.
Okay,
I'm not sure,
so
like.
yeah, that is true, but the importance of you know categorizing us, assigning which is what, is because the inherent methods of analysis differ based on the type of variable. So the measures that we calculate will differ, and the analysis that we do will also differ based on the type of variable that we are working with, because whatever can be interpreted in a qualitative sense may not be, not be readily extended to a quantitative sense, right? So that is the broad reason. What you said is absolutely correct. If we have something continuous, we can do different sorts of plots and different sorts of graphs, but the graphs will also change depending upon the type of variable under consideration. So broadly, there are two types of variables. One is the qualitative, or as we say, categorical variable, and the second type is quantitative, or mostly numerical, yeah, numerical variables. And there are two subtypes, nominal and ordinal. So there was this question asked by Ashi, I don't know if she is here or not, in the discussion forum, that uh, uh, it was said that nominal categories do not have any inherent rank order, but ordinal categories have some ranking order. So can you help answer these questions, like what do you give, can you give me an example of a nominal category and ranked ordinal variable? Just examples. It can be anything.
Now,
Hmm.
a nominal data, maybe an example would be
uh, price tags
Can
price
you?
tags in a supermarket
Okay.
is for ordinary data. An example, the examination results. You can rank students according to who has scored the highest and who has scored the lowest.
So,
Nominal, I.
ma'am, is that so?
Example.
For example, if we decide in a classroom how many are boys and how many are girls, isn't it a example of nominal variable or nominal? You can say
No,
variable.
no,
No.
no, no. See, this
Ma'am,
is, yeah. See.
ma'am, I think for nominal qualitative data, we can take examples of gender
Okay.
uh, and nationality of a person,
Okay.
like if he is Indian or non-Indian,
Yes.
and for ordinal, I think ordinal is about inherent rank order. We can rank means middle income group
Okay.
or low income group, something like that.
Exactly.
Uh,
So, nominal means you will have some categories, category 1, category 2, category 3, and there's no preference or no, like, it's not that rank 1 is in any way better than rank 2, it's just categories. Like, suppose you have very naive example, let's say you have a red box, you have a blue box, and you have a green box, and you are putting, uh, let's say, pencils in each of these boxes, and there's no preference working here, just some belong to, like, when I don't know if you were in school, while in school we used to have houses, like some people would belong to some particular house, some people would belong to some particular house, but there was no, in no way was it that one house is better than the other, it was just mere segregation of the entire uh, population of students into four different groups with no preference or ranking. So that type of variables are nominal variables. As we said, that gender and nationality. That question about number of females and number of males, the focus is on number. That is a numerical variable. That is not a
Ma'am, it
categorical
can be,
variable.
ma'am, it can be come in discrete quantitative.
Yes, that one would come in discrete, that number of male students and female students, that is different. But this nominal variable is that the, as you said, like gender of a person, you could be a male, you could be a female, you could be a trans, there's no preferential thing or no ranking. But income, there's always a rank, it will be low, middle, high. So income or economic status, socio-economic status, so this is in somewhat ranked. Then education, educational qualification, this is also an ordinal variable. You could be a 10th graduate, you could be a 12th graduate, you could be some BTech BSc, you could be a master student, you could be an MBA student, and so on. So there's a hierarchy, an inherent rank order. So is the difference clear between nominal and ordinal variables? Like ordinal could be stages of a disease, like progress. Let's say if I talk about Alzheimer's or dementia, you could be normal. Few days down the line, you could be MCI. Then few days down, you could be AD, something like that. Okay, so this is disease progression. That rank order is working over here in some sense. Okay, so that is the difference between nominal and ordinal. Both are categorical, but for ordinal there is a ranking order. It's fine, right?
Yes, ma'am.
Yeah, understood.
Okay. And the next one is quantitative or numerical variables. So it could be discrete or continuous. So an example of a discrete variable could be number of, let's say, typos in a page. So it could be 1, 2, 34, 37, but these are all discrete numbers. You cannot say like there's a 36.5 number typos in a page. No. So that will be an example of a discrete variable. Or you could say number of times heads comes up when you toss a coin, let's say 100 times. So that is a discrete variable, right? And continuous is something which can be measured on a continuous scale. For example, let's say sugar levels in your body, or let's say anything. It could be anything. It could be weight, it could be height,
It
anything.
can be temperature.
Can be temperature, can be pressure, can be volume, anything. Okay, measured on a continuous scale. So these are some examples of discrete.
Ma'am, could you please repeat again what
Okay,
you said?
from where? If you can just give me a
Ma'am,
clue.
from quantitative, because one call is coming.
Oh, okay, fine. So quantitative is something which is numerical in a broad sense. Now, if you have distinct numbers like 1, 2, 3, 4, 5, something like that. So I was telling number of heads in 100 coin tosses. This is a discrete. It could be 1, it could be 2, it could be 0, something like that. And continuous can be the other category where it can take any value in the real line. Okay. So it could be your blood sugar levels, it could be HDL or lipid levels, it could be weight, height, temperature, pressure, anything of that sort. Even marks, if you can consider it that way, because some people do get some scores sometimes. It will depend on the context, but depending on that context, marks can also be taken as continuous. Or stock prices, like as you mentioned, that is also a continuous variable. Okay, so I'll just proceed. So as I was mentioning, so statistical analysis, and it was based on the hypothesis. Some hypothesis is getting tested, or there is some estimation happening. Estimation of the population parameter with the help of some estimate, and then some sample characteristic which is known as the statistic is used to verify my hypothesis that is being tested. Okay, so don't worry, it might seem a little difficult or not clear at this moment. When week 3 lectures, if you go through, you'll get a more clear idea of this statistical inference part. So what is the point of all of these? So the main two focus is forecasting and decision making. Like you were mentioning about the stock prices. So let this be some model of mine from where I'm getting some estimates, and that these, if some new x star value is provided, I will be able to get some predicted value which will help me in making future decisions. Like if I have a, let's say this is the graph of a stock price, let's say, so I want to know what will happen, let's say after 5 days. So based on this data, I will have to plot some sort of mathematical model, and from that my aim is to forecast or predict what will be the price of that stock after some days. So this price can depend on various other factors, including the price of the stock that is today. So the main goal is forecasting and decision making. So another concept that was discussed was how do we obtain the data. Whatever data analysis we need, the crux of the matter is data. So where do we get it from? Anybody remembers the difference between primary and secondary data?
Ma'am, primary data is that we research and obtain the data from first hand, and the secondary data is like we are getting data from another another source.
Okay.
Like
So this is collected first hand and this is obtained from another source. So an example of a primary data would be any survey that you conduct. Okay, so sometimes you'll see surveys coming up and campaigns coming up, they are getting data. So whatever data they are collecting, that is primary data. Now if I stored it in some repository and somebody else uses that data, then the same data becomes a secondary data to the group that is using it later. It's clear, right? You got the difference?
Yes.
Okay. So then economic data could be primary data. You could go about and collect your own data sets, or you could fetch it from a secondary source. Now it could be of three types: cross sectional, time series, or a panel data. So can you give me an example of a cross sectional data?
Uh, it is like a data set, whereas we have like rows and columns. For say, if we have male, female, and people who smoke and who doesn't smoke.
Okay.
For say male, how many are smoking? So there is a cross section, whereas we can figure out how many of them are smoking, and those are girls or boys.
So you are referring to some sort of this sort of a situation.
Right.
Okay. So if I broadly extend this thing, this is one second. This is some sort of a categorical data where you
Right.
have a 2 cross 2 data. Individuals are sorted according to their gender and their smoking status.
Right.
While this is correct, but this is not what we readily imagine when we talk of cross sectional data. Cross sectional data, uh, we can, of course, this is also some sort of cross sectional data, but cross sectional data is that when at a specific time point, let's say we have this same thing, the uh, let's say age of uh, 500 individuals, could be male or female or anything. Okay, so this one, let's say I'm denoting it by samples. So these are my 500 samples and I have the age. Someone is 25, somebody is 15, somebody is 16, and likewise. So if I am looking at the data in this fashion, I'm just looking at the rows, then this will give me some age distribution of 500 individuals at a particular time point, at time t0, let's say. So this is a cross-sectional data. Whereas if I consider any one sample and follow their mm, let's say I'll just change this parameter so that it is easier. Let's say I'm considering weight. Across rows, I have weight of an individual, weight of 500 individuals at a particular time point. Now, if I take data on one individual, if I focus on one individuals and follow their weight across time as they age, so sometimes it's 25, 26, 27, then 50, 52, then again something something something. Okay, so if I look at the data in this aspect, I'm following up with respect to time, then what we have is essentially a time series data. Like it could be stock prices. If I talk in terms of stocks, let's say I have 50 stocks, stock 1, stock 2, stock 50. On 4th February, what was their distribution? This will be cross sectional data. And now I'm seeing what is happening with time throughout February, March 2023, and let's say. So then this one will be my time series data. And if we take both the components together, if we study, then what we have is essentially a panel data where there are two components, both the cross-sectional component and the time component or longitudinal component. Is this idea somewhat clear?
Yes, ma'am.
Okay. Any doubts so far?
No.
Okay.
No, ma'am.
Okay, thank you. So, then we also discussed something about categorical data, and contingency matrix was discussed. There was some brush up about joint probability and marginal probability. So, I will just reiterate. So, whatever is probability of these events happening alone, those will be the marginal probabilities, and probability of these two happening together, those will be the joint probabilities. Like these individual cell probabilities would be the joint probabilities, and whatever is in the margin, that would be the marginal probabilities. And conditional is, if I have probability of A given B, what I'm trying to find out is out of all B, how many are A. So there was this question in the discussion forum from somebody with a mail ID TIDC. I don't remember. I don't know the name of the person, but I think they had problems in understanding these two probabilities. So, shall I reiterate what has been said here? I'll just do that. So, if the if let us consider this probability table where we have numbers on the example that you were giving, number individuals categorized by gender and their smoking status. So, these are my marginal probabilities, and these squares are the joint probabilities. So if the question is such that probability a student doesn't smoke and is male, it means male and doesn't smoke. So then this is 275 out of all 750. Marginal is that a student is a female. So that will be 450 by 750. Or a student doesn't smoke. That is this column total by the total number of individuals.
Ma'am, if we say that joint probability is we are taking two variables at a time, and for marginal probability, we are taking only one variable.
Exactly.
Okay. Okay.
So if you if I can draw this, I'll just let's say you have, I'll draw two Venn diagrams, okay? So this part is actually the joint probability, the intersection part. And A as a whole is marginal, B as a whole is marginal. Okay? So this is one such scenario. There could be several other scenarios as well. So when we are considering both the distributions together, then like male and smoking out of all individuals, that is this number, male and not smoking, not smokers. This one, it's that probability a student is male given student does not smoke. So in the denominator what we should have is that probability student is
Student
male.
male.
In the denominator we should have the total number of students who does not smoke. Who does smoke, sorry. So the total smokers is 65. That is what we have. Out of those 65, how many are male? So that probability is 25 by 65, this thing. Similarly, probability a student doesn't smoke given student is female. In the denominator, we should have the total number of female students, that is 450. Out of those 450, given that the student is female, so we have restricted our search space. Whatever is in the denominator, that is now our search space. So for the previous case, the denominator was student does smoke. So we restrict our searching within the smokers. So there are 65 smokers in such cases. Okay. But in the second case, our search space is only different. The space is among students who are females. We want to find out those students who do not smoke. So that restricted space now becomes 450, this one, total number of students in the population or in the study. This part is clear, right? I just wanted to reiterate because this was a question in the discussion forum.
Yeah, clear.
Okay. So the next thing that was discussed was, now that we have data collected from primary, it could be a primary data, it could be a secondary data, it could be categorical, it could be continuous or quantitative. What can we do with that data? So this frequency distribution can be computed from both categorical and continuous data. So here I have an example. Let's say in 20 homes, people were asked how many cars they own, and this is what the 20 families or homes they reported. So if I have to draw a frequency distribution of the cars, what I'll do, I'll just first find out what is the minimum in the data set and the maximum. So here the minimum is 0, as you can see, and maximum is 4, and in between there are values. So now frequency is nothing but, frequency means counts. So we'll just count how many number of these variables are present in the data set. So here we can see there are 1, 2, 3, 4. 4 zeros, 6 ones, 5 twos, 3 threes, and 2 fours. So then this is the frequency table that I can construct. Okay, now here you have 20 homes. It's fairly easy to get each and every frequencies of each and every value of the x. So one more thing, if I have to categorize what sort of number of cars is my variable of interest, so is it a discrete variable or is it a continuous variable?
Discrete.
Yes.
Discrete.
This is a discrete variable, right? So sometimes what happens, if there are huge number of discrete variables, here we had 20, it was easier to get a frequency distribution like this. But sometimes let's say we have 1000 variables, 1000 homes or 10,000 homes were sampled, and we have these number of, sorry, so when the number gets large, or the variable is a continuous type of variable like age, let's say, or weight, let's say, so at that time constructing such frequency tables doesn't serve the purpose. So what we do at that point, we group data into class intervals.
Class intervals.
Yes, and then we try to get some frequency and other such categories or characterizations of the data. So this was already said, the number of classes, it's recommended to be between 5 and 15. I'll give an example, so don't worry, just bear with it. And these a few terms were introduced in the class. So range means maximum and minus minimum value of the variable whose frequency distribution I am considering. 1 second. Whose frequency distribution is under consideration. And it is different from class width in the sense that normally the normal consensus is that class width is the range divided by n, that is per class what is the interval length, that we call as class width. I think Aishwarya had a doubt. Are you here, Aishwarya? Okay, she's not here. But there was this question that what is the difference between range and class width. So if I have too large a data set, I divide it into groups, and each group, let's say, has some class intervals. So let's say this is 1 0 to 2, this is 2 to 4, this is 4 to 5, and this is, let's say, something like this. So these 6 8 10 like this. So this width is the class width. Now if my data set starts from 1 and ends at 9, then the range will be 9 minus 1, that is 8. Okay, so that is the difference between class width and range. Range pertains to the data set, whatever data I have, the maximum minus minimum. And class width is that when I group it into certain specific groups, what is the length of the interval that I am considering for each of the classes. Okay, and these concepts were introduced: class limits, upper class limits, lower class limits, class boundaries, frequencies, relative frequencies, and cumulative frequencies. I'll just give an example so that we are clear with what we have. So this is an example where 30 batteries were tested to determine how long they could last. So this is essentially the variable under consideration is battery life in minutes. So seeing this, what do you think? What type of variable is this? Is it a discrete variable? Is it a continuous variable?
Continuous.
Okay, it's a
The
continuous
values are discrete, but generally battery life statement itself says it should be continuous.
Exactly. So maybe because of the limitations of our measuring instrument, we got this as a discrete variable, but in essence it is a continuous type of a variable. Okay, so the minimum value of these 30 batteries that were tested, the minimum life was 363 minutes. Okay, and the maximum was 431. So the range of values is 68. This minus this. So hypothetically, this is an example I took from this website. You can check this out. So hypothetically, let us construct 8 classes. Okay, instead of 8 we could also have constructed 10 classes, 12 classes, 15 classes. But the point that we should remember is that after our main goal, or we are moving towards visualization. So it is, we don't want our graphs to be clumsy and cluttered. We want clear visualization, and that can, so that we can extract information in a very efficient manner. There should not be too many classes, and there should not be too low a number of classes also. So this example, they have taken 8 such classes where they have first, let just forget about this part and consider the first column only. So they have categorized the battery life in minutes into these groups: 360 to 369, 370 to 379, and so on. So these, for each of the classes, so let's say if I consider this class, then the lower class limit is 390, the upper class limit is 399. So this column is basically giving me the class limits. And within these boundaries, so whenever we are considering class limits, it should be non-overlapping. Because if I do this 360 to 371 and again take from 370 to 379, if something falls in, if something is 370, we don't know in which class we have to put it in. So the rule is, whenever we are considering class limits, they should be non-overlapping. Okay, so this one we have done. And
So I have a question here, ma'am.
yes.
First, say example, we have the first width is 360 to 369. And next one is 370 to 379. What happens if something comes in between 369 to 370? Where does it fall?
That is what I'm saying. In this data set, we don't have something like this. But if we have, then we don't know, if this sort of a limit is taken, we don't know where to put it. So based on my data set, suppose I had something like 639, like let's say 369.5, then I would have to construct my limits in such a way such that this falls in only one category and there is no double count. So then I would have modified my class limits to something 360 to, let's say, 371, then again 372 to something like that. So that will depend on the data that you are using. This is precisely my point.
Okay.
So once you have the class limits, you can just count the number of variables falling within those limits, count the number of observations, and get the frequencies as we get here. Now this choice of class limits is variable. It depends. It's very subjective. You could take 8 classes and some particular class limit. You could also do something like take the minimum value as the lower class limit of your first class, and then you add the class width, something like that. So 68 you do by some 8 classes or something like that. Let's suppose if it is 70, I divide it into 7 classes of each with 10, then 363 plus 10, then again from that plus 10, like that. That is also one way of constructing my limits. So this part is very subjective. Then we get the frequencies. Now whenever we are talking about class boundaries, there the important consideration is there should not be any gaps, because these boundaries are what is later on used to construct a histogram. The difference between class limits is that class limit, they should be distinct, there should not be any overlap. But whenever I am considering class boundaries, there will be some sort of overlap. So how did I do it? The class boundaries, nothing, I just took 370 minus 369 by 2. This is 0.5. We add UCL plus 0.5 and LCL minus 0.5. As simple as that. 1 second. Okay, and this is how we construct the class boundaries. The next task is to get...
Ma'am, can you please repeat the class boundaries?
Okay, so class boundaries is you have to consider so that the upper class boundaries of the previous class and the lower class boundary of the next class is the same. So one way to go about it is that because we want uniform width for all our calculations, I'll just take the difference between lower class limits of the second class and the upper class limit of the first class. So that is 1. I divide it by 2 because I'm going to give some of the difference to this class, some of the difference to this class. So what I am doing essentially, this 370 minus 369 by 2 is 0.5. So I am subtracting 0.5 from the lower class limits. So 360 minus 0.5 is 359.5. And I'm adding that 0.5 to the upper class limit. So then it becomes 369.5. So if I move on to the next one, from 370 I'm subtracting 0.5. So then I'm getting 369.5. Now you see there's no gap between these two.
Okay, ma'am.
Understood? Okay. This is how we construct class boundaries. Now difference is that class boundaries will not have any gap. Now once we have the class boundaries, we calculate relative frequency. Relative frequency is nothing but percentage of variables or observations in that group. So in total there are 30 batteries that were tested, out of which 2 fall within this group. So the relative frequency of this group is 2 by 30, which is 0.067. Similarly, for this group, let's say the relative frequency of this group is 4 by 30. So one thing if you can realize is that sum of this column will always be 1. This is you can see, right, the intuition. So
Yes.
okay, so once relative frequency is done, now relative frequency will lead to some, the similarity between probability and relative frequencies. So this column is of importance to us. So if you are asked to construct a relative frequency table, all you need to do is get the frequencies of each of the classes and get the proportion of observations lying in that class. As simple as that. And the second thing is cumulative frequency. So for cumulative frequency, what we do, we take the first one. For the first class, we take it as it is. From the next classes, we just add the frequency of the current class to whatever we had from before. So cumulative frequency of this class is 2. Of this one means this is 2 plus 3, this is 5. For this one it is 5 plus again this 5, that is 10. For this class it's 10 plus 7 and so on. This is cumulative frequency of less than type. Okay. So essentially what we are saying is that we want to find out number of observations less than upper class limit of this class. So here we have 2 observations less than 369. So if I want to find out number of observations less than 389, then that is what I'm asking for is the cumulative frequency. So I'll just add whatever I have till 389. That is 2, 3 and 5, and I'll end up at 10. Clear?
Yes, ma'am.
Okay. So once we have these cumulative frequencies and relative frequencies, we can go ahead and construct histograms. So in my x-axis, I will have the class boundaries, and in the y-axis, I can have the frequencies, the normal frequencies, or I can also have the relative frequencies. Now, when I'm going to construct a histogram, when I have a continuous variable. Okay, this is an important consideration. For discrete variables, we can draw bar graphs. For qualitative variables, we can get pie charts. But for a continuous type of variable, we will prefer a histogram. We'll do a histogram. It's not a question of preference. We'll just plot a histogram. The second one that was taught was ogive. So ogive is nothing but plotting the cumulative frequencies. So as I was saying, see, this point is 369. This point is 379. So what of less than type? So what essentially we are plotting is that the number of, so this point says that there are 5 observations below or equal to 379. This point says that there are some 27 or 28 observations below or equal to 419. Okay, so this is another type of visualization of a continuous variable. And then we moved on to some descriptive statistic, which is nothing but which projects some characteristic or features of the data. So there were 2 categories of measurements. One was the moment based measures and one was a non-moment based measure. So we had, for moment based, we had mean, variance, standard deviation, and for non-moment based we had mode, median, range and interquartile range. For these 2 features of location, spread and of symmetry. So what do we mean by location, spread and symmetry? So by location, I want to find out some sort of central tendency. What is the center of this data? That measure of central tendency can be moment based or can be a non-moment based measure, and likewise, consequently, we could have mean or mode or median as a measure. Just keep these in mind, what type of measure we want for these features. So central tendency is the point or the characteristic where the data is centering or clustering around some region. Okay, so this is my frequency or relative frequency, let's say, and here we have the x values. So wherever the frequency is more, somewhat so we can say that more data is clustered around this point, or in some way we can say that it falls in the middle of this data set from where to where it's spread. That is broadly speaking, a measure of central tendency. If I have to consider spread, let's say this is my relative frequency, this is my data value. If I have a curve like this, so then minimum is here, maximum is here, and I have something like this. Okay, minimum is here, maximum is here. So for the second graph, the spread is more, and for the first one, the spread is a little less. So the diverse the data is, the more variance we would expect. Okay, so that measure of this spread, this essentially quantified in some sense is dispersion. And skewness, by skewness what we mean is that if this is the central point where my data sets are clustering, if I have something like this, that on the left side also it's similar, the spread and all, it's not distorted, it's not like something like this or something like this. No, it's sort of symmetric about some value, symmetric about the mean or measure of central tendency. Then that point, this phenomenon is known as skewness, if we have some asymmetry in our frequency distribution. For example, if we go here, the distribution seems fairly symmetric about this point. It's going up and it's going down. But this one, if you see, if you look carefully, it appears to be, no, this is the same thing, but if I have something like this, then what we are seeing, something like this. So there it appears to be a little distorted. So if you get some graph like this, which is not exactly bell shaped, it could be a little skewed. This is just the idea. Okay, and we also went through some measures of central tendency, that was mean, median and mode. Mean could be of three types. One was the arithmetic mean, which is summation xi by n, the geometric mean, product xi to the power 1 by n, and the hm, that is the mean of the ratios, 1 by summation 1 by xi, sorry, n by. Okay, so these things are known to us, and this is the usual relationship between harmonic mean, geometric mean and arithmetic mean. And there's this relationship also, am into gm, hm equal to gm square. But what we should be careful about when selecting these measures is how and when we should use it. For example, if we have a variable which can take negative values, we will not use geometric mean in that case, or harmonic mean also. So if we have some exponential variables, some rate of change, those situations will call for some measure of geometric mean. And also we spoke about median, which is nothing but median is a middle value. Median of a distribution or a group of observations is that point above which half of the observation lies and below which half of the observations lie. So this middle value, when the variable is ranked, is known as median. And this is preferred as a measure of central tendency when we have two extreme values, two extreme value. I'll tell you the motivation behind using median. So let's suppose this is the income distribution of individuals. Let's say this is 1,000 per day, this is some 1 crore per day. Okay, this is the income distribution. So in any economy, especially in a lower middle class economy like us, it is expected that there will be more, this is frequency, okay? So it is expected that there will be more people on the lower end of the spectrum. Now, if I want to find out average income of a person in India, let's say, okay. Now, if I have to, mean is what? Mean is x1 plus x2 plus some, the nth in crores, 360 something crore, by the total number, the population of India. Now, this section of the population, the frequency is very low, but the actual value of x is very high. So if we include this one and use mean as a measure of my central tendency, because of the presence of a few millionaires and billionaires, the actual average of a country should be here. But because of the inclusion of these supremely rich people, the mean can get a little shifted, and we could get something which is not the true picture. In such scenarios, if we use median as a measure, then we can say that okay, half the population is in this side, half the population is in that side. So that gives a more, what do I say, a more representative figure, and that can actually be, used for our forecasting and prediction, because we know that these extremely high income people are very rare. They, including those observations in the calculation of arithmetic mean, will just pull the mean towards themselves, which is not actually what is happening in India. Is the idea, I mean, was I able to communicate why we use median in case of extremely skewed distributions?
Can you please repeat it once?
Okay, so what I'm saying is that when I have extremely skewed distribution, presence of very high values will pull. So let's say here, I'll just give you an example. Here we are considering average income of 10 people, okay? We have, let's say, 9 people from the service class and 1 millionaire. So let's say this is 10k, 11k, something like this. Total is somewhat 90k, and this is 10 to the power 6 something. This will be 10 to the 9 into 10 to the power 4. So if I add these and then divide it by 10, whatever number I'm getting is not actually a representative of average income of people in our country. Because these values, even though present in a very small section, these will pull the mean. So if I want the average income of any person here in India, let's say, I speak of the common people, okay, and I don't speak of course I take all the low, middle and high income people into consideration, but if I also take millionaires, then their salary figures will pull the mean towards this center, and that will not give me an actual picture of what is happening in India, being a middle income country. Was I able to communicate what the idea is there?
Yes.
Okay.
Yes, ma'am.
Okay. Anupama, did you understand? I think you only asked a question.
Yes, ma'am.
Okay. Okay, so that is the reason why, in case of extremely skewed observations, we prefer median over mean as a measure of central tendency. So, if this is one such property, if mean, median and mode are equal, then the data is not skewed. It will be a proper, like, bell shaped, if this is the mean, median or mode. So there will be no distortion in the frequency distribution or in the diagram. And
Ma'am, in your last slide,
hmm,
like if you can go back.
this one, this one.
Similarly, the thing that you said is because of this median. Why exactly we are taking median? So, does it have an angle of mode as well in this case? Since that is also part of central tendency.
Yes, angle of mode is that mode is
In what all
usually
scenarios basically we will have
actually
this kind of?
mode is more used when we have categorical data or qualitative. Suppose you consider votes. What is that?
Okay.
That is mode only.
Mode.
There's candidate A, candidate B, candidate C, whichever has the highest frequency, that we are taking as representative. So in voting scenarios, we can't take mean or something like that. Number of mean of votes is will not give us, like, these are categories, right? We have to select someone who will represent the population. So a classic
So,
example of mode is votes.
do you remember any of the examples whereas because of the mode, like the skewness increases or the bell curve is not symmetric?
Actually, there's a relation between mean, median and mode, and based on that, the skewness of the curve will depend. That depends on the relationship, or it's a two-way thing. I'll come to that. What happens if
Okay.
mode is greater? What happens if mode is less?
Okay.
Something like that. I'll come to that. So
Sure.
here, I'll say it. I don't know whether you'll be able to appreciate it now. Here, this highest point is the mode. Okay, this one will be, if I say if it is the median, since it's a positively skewed graph, the mean I was telling, no, it will be pulled towards the higher end. So here we have mean. So in positively skewed curves, we would see that mode is less than median, less than mean. Also, from the other end of the spectrum, if we have something extremely negatively skewed, then the mean will be less than the median than the mode. So based on these three measures is also a way how you can visualize, or rather intuitively find that if nothing is given, if no data is given, just the summary measures are given, mean, median and mode, from there you can get an idea of how the skewness of the data is, which end is a little longer or shorter or something like that. I'll reiterate this thing, but could you get what I was trying to say?
So what I understood is, like mode remains at the extreme end, wherever the bell curve is at the top end.
Yeah,
Generally, we will have the mode there, but
exactly.
median is always in between both mean and mode.
Exactly. And it could coincide also, mean, mode, median and mode could coincide also, but in that case
Yeah,
we will
that
have
is
a
perfectly bell
perfectly
curve you're
perfectly
talking
bell
about.
curve. Yes. Okay.
Yeah, understand.
Okay, so this one was this measure of central tendency, as I was talking. Then so whatever I discussed here is based on grouped variables. Now if I have to find out the mean and median, because normally it's very easy to find out the median and mean. So here I was supposed to say I forgot, so I'll just add one. Suppose you have a few observations: 5, 6, 7, 9, 2, 3, 11, 12, 13. If I have to find the mean of the observations, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll just sum up all of these divided by 9. This is case of ungrouped data. Okay. Summation xi by n. If I have to find out the median, then the first step is to arrange in ascending order. So if I have to arrange this, what I'll get? 2, 3, 5, 6, 7, 9, 11, 12, 13. So here my n is 9, which is odd. So if n is odd, then the median is n plus 1 by 2th observation. This is very crucial. Not n plus 1 by 2, but n plus 1 by 2th observation when we have everything ranked in order. So here this is the 5th observation. 1, 2, 3, 4, 5. So this is my median. So now you see this value divides the entire data set into two equal halves. What is above it and what is below it. 4 observations below it, 4 observations above it. So this in such a data set, this value is the median. Now this is the case when n is odd. But what happens when n is even? Suppose with this value 2, 3, 5, 6, let's say 2, 3, 5, 6, and what was there? 7, 9, 11, 12, 13.
N by 2th
7, 9,
observation
11,
and
12, 13.
n by 2 plus 1
Okay. Let's say I
observation.
have one more observations here. So here n is 10. So in that case, the median is average of n by 2th observation and n by 2 plus 1th observation. So here it will be average of 5th and 6th observation. 1, 2, 3, 4, 5. This one, 6th. So the median will be
6 plus 7 by 2.
So if 6.5 is the median, then this value is dividing my entire data set into 2 equal halves, 5 above, 5 below. I hope this is clear. So that was the case when we did not have any grouped frequency distribution. Now what happens if I have a grouped frequency distribution? In case of mean, this is my formula, x into frequency by summation of frequency. I will weight each of the x observations based on the frequencies. So this actually is a weighted mean. Now, if I have intervals, class intervals, which of these shall I take as my x? I could take this, I could take this. The general convention is to take the midpoint of the two class intervals. So for this class, we'll take the midpoint between these two. 360 plus 369 by 2, that's 364.5. And this one will input as x. So it will be nothing but 364.5 into 2 plus 374.5 into 3 and so on and so forth, divided by summation f. The total number of the total frequency is 30. So that divided by 30 will give us the mean of a grouped frequency distribution. Okay. Now
Same as weighted average because we are multiplying
exactly, this is exactly a weighted average where frequencies are my weights. You're correct. This is actually a weighted average.
Okay.
Where frequencies are my weights. Okay. So now I will talk about median. How to calculate median of a grouped frequency. So this is the formula. Now how I'm going to do it is this. N will always represent the total number of values that you have, irrespective of being odd or even. Doesn't matter. Okay. So whatever n you have, n by 2 you have to calculate and put it over here. B, so here in this example n is 30. Okay, and n by 2 is 15. So after here I'm going to scan and find out where exactly this number is falling. So 15 is less than 17. The number just exceeding 15 in this cumulative frequency column is this category. This number 17. Okay. So then this will be my median class. Now L is nothing but the lower class limit of the median class, which is 390. Class width is 10 and class width I am calculating this minus this. Okay, that is the class width. And B is nothing but the cumulative frequency of the class preceding the median class. So B is 10 and G will be the actual frequency of the median class. So this is how we calculate median when we have a grouped frequency distribution. So what we are going to do step by step, first just we have to get the total number of individuals or observations that we have divided by 2. Go back and see where the number just above it, in the cumulative frequency column. So here it falls, it is less than 17. So this is the median class. We have to take the lower class limit of the median class, the cumulative frequency until the median class, and the actual frequency and class width. Substituting the values, we will get median. Okay, I'll share the slides so you don't worry about the numbers. You'll be able to understand. So this is fine, right? How we are going to, the important thing is that for an ungrouped frequency distribution, it would depend on whether n is positive, if n is odd or even. But in case of a grouped frequency distribution, it does not depend on whether n is odd or even. This is what I wanted to convey. Okay, so next thing what I'm going to do is that I'm going to talk about some measures of dispersion. So as I was saying, dispersion is a measure of how diverse or what is the spread of the data. So here we have talked about something called population variance, population standard deviation, sample variance and sample standard deviation. So if you remember, we were talking about this is a population, and from the population we draw a sample. So population parameters are mu and sigma. We actually don't know. Why we don't know? Because of constraints of time, money and everything. Suppose today if I have to find out the height of all individuals in India, I do not have the resources to go about and ask each and every person, what is your height? Take the average height and also get the a measure of the population standard deviation. I don't have that. But what I can do, I can sample individuals from each of the states, and then based on that sample from this sample I could calculate x bar and s square, that is the sample mean and sample standard deviation, and I could say that these are these are my estimates, and these could be representative of the population parameters which are unknown to me. I could say something like this, and also I could also say that this, there could be so many properties that this tends to this when n tends to infinity, so many things. I'm not going into those things, but this is the basic difference. When I'm talking of population, the parameters measuring the central tendency and the spread of the population is unknown to me. But when I have the sample, I can readily calculate the sample variance and sample standard deviation. So this is the formula. Steps remain the same. You just have to calculate the mean of the distribution, take the deviation of each observation from the mean, square it up, sum it up, and then divide by n or n minus 1 based on the if it's a population standard deviation or a sample standard deviation. Okay, so for grouped data, this will hold if we have ungrouped data. But for grouped data, this x bar will become the weighted x bar, and we would also multiply each of these squared deviations with the frequency of the group under consideration. So for example, if I have something like this, let's say these are my class limits, okay, 10 to 15, 16 to 20, something. So this will have some midpoint, 12.5, 17 or 18.5, something like this it would have. These midpoints would be my x's. x bar would be, the frequencies also I should have 2, 3, 5. X bar would be summation xi fi by summation fi. And then let's say this is something 10. So then x minus x bar would be 12.5 minus 10 whole square. 18.5 minus 10 whole square. And whatever we have, we'll just add that up, add all of these things up, and we would get summation xi minus x bar whole square. This thing will divide by the total number, or summation fi. But each of these should also be multiplied into with the frequencies. Shall I repeat once again? I think you could have gone confused.
Yes, yes.
I'll just
Yes,
repeat.
please.
I'll just repeat 1 second. So this is clear, right? In case of a grouped frequency distribution, we would consider the midpoints. That part is clear.
Yeah.
This is clear. Okay, so let's say between these 20 to 25, 22.5, these are my intervals, midpoints. Just hypothetically consider these are my midpoints. So I would have to find out x bar. This is my first step. So for a grouped thing, x bar would be 12.5 into 2 plus 18.5 into 3 plus so on and so forth, divided by the total number that I have. Right. So once I have this x bar, what I'm going to do is that I have all these midpoint x, 12.5, 18.5, 22.5 and so on and so forth. My x bar, let's say it turns out to be 10. Okay, so what I'm going to do is that 12.5 minus 10 whole square into the frequencies that I have, 2, 3, 5 into 2. This would be 18.5 minus 10 whole square into 3. This would be 22.5 minus 10 whole square into 5. So this is nothing but xi minus x bar whole square into fi, this column. And I'll just sum it up. Then I have summation xi minus x bar whole square into fi. I divide it with n, and there I have the n or n minus 1, and I have the sample standard deviation. Is it clear now? I'll just wait for a couple of minutes.
Yes.
It's clear, right?
Yes.
Okay. So that was one measure of dispersion, like the standard deviation or the variance. Now I must say this was a moment measure. If you can see here, variance and standard deviation is a moment based measure. A non-moment based measure is the range or interquartile range. Now why range? It's very clear. If as I was saying in this graph, if you remember, here I was saying, so maximum minus minimum is my range. So the larger the range of a distribution is, the more it is spread. If maximum and minimum lie very close to each other, then it's not spread over a large distance, right? But if they are far apart, then it's spread over a larger region. So range is one natural measure of spread. Another measure which is not based on the moments is interquartile range. Now, quartiles or percentiles are points in the data set. So if I have such a data set like this, if I can divide it into 100 equal parts, then each of these points would be my percentiles. So P50 is nothing but my median, because P50 will give me the point below which 50% of the observations lie. Okay.
Okay.
Okay. So if that is percentiles. Similarly, we could have quartiles. Quartiles will divide the data set into 4 equal parts. So Q2 again is my median. Okay. So Q1 is basically that point below which 1/4 of the observations lie. Q3 is that point below which 3/4 of the observations lie. So interquartile range is nothing but the difference between these two quartiles, Q3 minus Q1. IQR is Q3 minus Q1. So here I have an example. So let's say we have these many observations. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. Okay. So I have here n equal to 10. So fifth and sixth observation by 2 will give me my median. So that's what I have done. 23 plus 25 by 2, 24 is the median of the observation. Now if I have to calculate Q3, Q3 again divides this half into 2. So now I have reduced number of samples. Here I have 5. So then the third observation is going to be my Q3. And for here also, the third observation is going to be my Q1 for this end of the spectrum. Because see, when we are, one second. So this is my distribution, the entire thing. I'm cutting it into half. This is giving me my Q2. Again, this one I am differentiating into half. Out of all these observations, half lie below this point, half lie above this point. So this point is somewhat a median of only these observations. This is nothing but Q3. Half, half. And this is also nothing but half, half. Of half. So essentially, this part is half of half, that is 1/4. This part is also 1/4. This part is 1/4. This is also 1/4 in total. So this point is Q1, below which 1/4 observations lie. This is Q2, below which half plus half, half the observations lie. This is Q3, below which 1/4, 1/4, 1/4, 3/4 observations lie, and so on. You got my point?
Yes. So when you say Q3 minus Q1, so does that mean if in a graphical representation, that means everything starting from 0 to Q3 minus 0 to Q1, right?
Exactly.
Okay.
But the point is, when I say Q3 minus Q1, I am considering Q3 is that value of X. It's not based on the frequency. It's based on the actual value of the variable. So here,
Okay.
if I have this graph, here I have the frequencies, let's say, but here I have the X values. These points are my Q2s, Q3s. Okay, it's not based on the frequencies, but it's based on the actual observed X values, observed values of the data set.
Okay.
Okay. Okay, so this is what we have in interquartile range. But why is this important? This is also used for outlier detection. So if this graph can be represented in this figure, okay, the same thing, this point, most of you must have plotted a box plot. So if you get any data, go to any software and just plot a box plot. You will find a figure like this. This line is the median or Q2. These are the Q1 and Q3 points that we have. This one is Q3 plus 1.5 IQR. And this point is also Q1 minus 1.5 IQR. Now, if any observation lies here beyond these two cutoffs, those observations are flagged as outliers in a box plot. So this measure.
But ma'am, I'm just I have a question here. When you put these two dots beyond these two candles, 2 points, while calculating this median value, that is Q2, Q1, and Q3, we always include those.
Yes.
Those are already
Yes,
included,
those
right?
are already
In that
included.
range.
Yes, see, that is what I'm saying. When we are calculating median, it's not affected by extreme values because we are just segregating based on how many observations are below it, how many observations are above it. We are not considering the extent to which it is different. You see,
Okay.
this point could have been here also. Then we would not have excluded it, because median, calculation of median will not depend on the values of the variable. If you see carefully, whenever we are considering the uh, median, we are not putting so much of focus on the variable
Right. Extreme value. Right.
extreme value at point. For what we are doing is that we are dividing the total into two first. Then we are seeing, okay, how far does this go. Then after everything is done, the first thing is calculating this median class. So once that is done, then we are taking okay, what are the limits and where can the median values lie. After this point we are considering. So if we have a value like very extreme 479 point something here also, let's say we have some 2 here, my median is not going to change so much. Median will remain here itself. But that observation will be flagged here. See, because that is an unusual observation. And if you do data analysis, what we do is that we usually remove the outliers before proceeding, so that our measures and our variables and everything, the analysis is more accurate.
Okay, just one question. For
Yes.
this type of analysis, don't we prefer normal distribution, like standard deviation, this stuff?
See,
Because in the
standard deviation you can calculate for every distribution. It's not specific to normal distribution. We prefer
okay.
normal distribution because it has some very nice properties, and
Mhm.
the methods are mostly developed keeping an underlying assumption that data set is normal, because it gives us some nice properties. That is the main reason. But you
Okay.
could calculate, see, these are measures of central tendency. This does not, I am not talking about distributions here anywhere. You just have x's, you can calculate, and their frequencies,
Okay.
irrespective of the shape of the graph.
Okay.
Okay, so of course we prefer normal distribution in some scenarios because of some downstream properties, but that is not based on the mean and standard deviation or something like that. Okay, so here was another example where so as I was saying, q1 you can also get it as p25. This is p50, p75. Okay, because 25% of the observations, because p is percentile, 25% of the observations lie below q1, so this is also p25. I hope you understand this one. So here an example was given on how to calculate the percentile groups. So here the total is, you see, 121. So n by 4 if you do, then that will fall in this group. N by 2 if you do, it will fall somewhere here. N by 3n by 4 if you do, it will fall here. So this is not a group data. So directly you could say this is q1, this is q2, and this is q3. And you could also calculate the interquartile range, the skewness measures, and so on and so forth. But if you have a grouped frequency data, then the one second. So if you have a grouped frequency distribution, you remember the median formula, this one. So for median it was n by 2. For q1 it will become n by 4. For q3 it will become 3n by 4. And the calculation proceeds exactly in a similar way. So here n is 30. If I have to find out q1, then n by 4 will be how much? 7.5. So I'll just look which is the class. This will be my class because it just exceeded 7 and it's within 10. So in that case, this would be my lower class limit. Cumulative frequency B till the previous class would be 5. So here this would be 380, B would be 5, G would be 5, and width would be 10. So doing all calculations, I would get Q1. Similarly for Q3, this will be just 3n by 4. Wherever it comes, which group it falls into, I'll consider and carry out similar operations and get Q3 in case of a grouped frequency distribution. Is it clear? Just try to remember this formula and the meanings of these abbreviations. So this is the same thing, the 20 car example that I was giving. So as we can see, mean we can calculate xi, fi, by summation fi. Median we'll arrange, or how will we calculate? 6 plus 4 10 15 18 20. So n by 2 is 10. So cumulative if we do, so then here my observation lies, so median will be 1. Mode will be that number, that x for which we have the highest frequency. So mode is also 1. Variance similarly xi minus x bar whole square by n, and SD would be root over variance. That's it. Okay.
Okay.
And lastly, what was discussed was a measure of skewness. So, sorry, is my slide changing? I cannot see it. Clicking on it, it's not changing. Can you see the heading measures of skewness?
Yeah, we can see only those
Only this one, right?
left
Okay.
symmetric, right skewed. Yes.
Okay. This one you can see now.
Yes.
So, as I was saying, measures of skewness. So, Carl Pearson suggested two measures. One was this mean minus mode by standard deviation, and empirically it was shown that mean minus mode.
Can you just repeat? My connection was lost.
Okay. So, this Carl Pearson suggested two measures of actually one measure of skewness, that is mean minus mode by SD, and empirically it was shown that mean minus mode is approximately 3 times mean minus median. So using this relationship, this second measure was also devised. So this is one measure of skewness. Now the problem with this is unbounded. It could take any range of values. So if I have to compare between two, then it's fine. But there is no absolute bound that between here to here. We want measures which are bounded so that we know how large is large. If I have here a very high value, we don't know if it is extremely skewed or not, because we don't know what the maximum value can be. So for each of the measures, usually we would prefer to get something bounded. Like for example, measure of correlation, let's say, okay, R square measure, it will be 0 to 1. So the closer it is to 1, we can say that it's a good fit. But if this measure is unbounded, we don't know what we can call a good fit. So that is why we would prefer Bowley's measure of skewness over Pearson's measure, and it is devised in this way. It's the difference between the quartiles. So what we do, we take difference between this portion and this portion and divide it by the interquartile range. Q3 minus Q2 minus Q2 minus Q1 by Q3 minus Q1. So this is Q3 minus 2Q2 plus Q1 by the interquartile range. This measure is a very well behaved measure because it lies between minus 1 and 1, and the implications are such that if the measure is 0, we get a normal symmetric curve. If it is positively skewed, then we get a curve like this. Right skewed means positively skewed. And if it is negative, if the measure is less than 0, then we get a negatively skewed graph. Okay. And as I was saying, here for a left skewed graph, you see this point is the mode, highest frequency. So mean, because there are too low figures, these would bring down, will pull the actual mean towards themselves. So you would have mean something like this. For this reason, mean is less than median, less than mode. Similarly, in a right skewed distribution, because of the presence of very extreme high values, the mean would get pulled towards this end. And this is the median, and this highest point will be the mode. So then mean is greater than median and it's greater than mode. Okay, so I hope I was able to convey the ideas that were discussed during the week 1 lectures. So if you have not solved the assignments, you can go ahead and do it. And if you have any questions, see, I cannot discuss assignment questions until and unless the solutions are available. So if you need any help with that, you can always ask in the live sessions and in the discussion forum, but I won't be able to give you an answer, a definitive answer of the assignments, uh, as long as the deadline
Ma'am,
is not over.
can you please send this PPT?
Yeah, I'll send it. I'll not send it directly. It will be uploaded and shared with from NPTEL. So my actually this session is also being recorded. So both the recordings and the slides will be available for you to check out. And if you have any doubts from today's sessions, from week 1 lectures, if I've missed something, you can always tell me right now even, or you can post it in discussion forum, whatever is convenient for you.
Thank you.
Okay.
Excuse me, ma'am.
Yes.
Thank you, ma'am.
Thank you.
Ma'am, could you just brief me about the concepts of regression and correlation?
Okay, so regression, as I was saying, is nothing but the relationship between a dependent and independent variable. So usually independent variable is denoted by x, dependent variable is denoted by y. So you want some y to be some function of x, and there will be an error term involved because these are not definitive mathematical models, but these are empirical models. So there will be some amount of error involved. So linear model, what it does is that it specifies a functional form which is linear in parameters, and then we just let's say if this is something like this, we assume this is something like this, we just get from the data, we get values of beta 1, the estimates of beta 1 and beta naught, put it in the equation and get some predicted value. So this then becomes my regression model. This is just a very brief of what we mean by regression model. I would advise you, there was a course last semester, NOC 55 MA 55. I'll share this slide with you. Here you will find the course lectures on regression analysis. This was a detailed course, and I had also taken some problem solving sessions. Both the links are given in the slide. So if you want to brush up your or know more about regression analysis, I would suggest you go through these lecture series and the slides. It's available on YouTube. Okay.
Okay, ma'am.
Okay.
Thank
Thank
you.
you.
Okay. Thank you. Any other questions before I stop this session? Or feedback or anything you would like, you can share.
Thank you very much, ma'am. It was
Okay.
very nice.
Okay. Thank
Uh,
you. So every Saturday from 6 to 8 there will be these sessions. If you find these interesting, do join, and if you have doubts, please, I would suggest you join and get it cleared instead of posting in discussion forum, because there could be some time lag between your doubts and the time point when it is addressed. So I would suggest you
sure.
join and get it cleared.
Okay.
Okay.
Thank you.
Thank you so much for joining. Thank you.
Thank you.
Bye bye.